Hello everyone, this is Bradley. As you have seen, I've made 4 testing animations these days. 4 animations have similarity and differences. Before I went to super details in how to do each of these animations, I wish to discuss the foundation of their important similarity, so that later on I don't need to repeat what I have said. So I don't know if you realize, in all of these 4 animations, the objects change their colors or even shaders. In the first animation, objects change from blue to yellow. The second animation from brown to brown and green. The third animation, objects has been lightened up. The fourth animation, objects has been lightened up, also change their colors depending on their exact status. They're basically blue metal balls in the air, but when they're close to the ground, they're emitting orange. When they're touching ground, they're emitting red. All these animation use a free add-on called Animation Nodes, which is a motion graphic tool in Blender. Just for knowledge, its initial developer, Jake's Luke, also turns to be the developer for new node-based particle system. Anyway, you can download the animation node from the link in the description. The question is, why do we need this add-on for this work? If you think about how to do this animation in native Blender, the thing that I can think is to create an individual material for each of these objects and animate the transition for each of these objects. This will be a horrible experience, but if you use animation nodes add-on, you only need one material, and the whole process of transition will tend to be automatic and procedural. The principle is to use a concept of falloff. Just to give you an example, in the area of falloff, the object is red, and outside the area of falloff, the object is blue. This doesn't only work for colors, but many other things like locations, scales, or rotation. But today we're going to specifically talk about shader, because this is a concept beyond the regular speech of animation node itself. So today's topic essentially is how to link the animation node to shader or materials in Blender. So now we're in Blender, and the first thing that I would like to show you is how to use the animation node to change the values in shaders, like change this base color from red to blue. And there are 2 methods. One method is to use the cycles material output, and you can call up this node by Shift A and go through materials, cycles material output. Or actually, this list is very long, so you can instead use this search panel, which has a shortcut of Control A. So I basically just hit Control A, cycles material output, so I got the node. And this is a very interesting node. You don't see a input and output. So just basically just choose a material and choose the node, principal BSDF, and choose a socket. So in this case, I'm already in this base color, and I'm going to change these values. This is done. So in this case, you might wonder, okay, why don't I just change all these values in the material instead of using animation node? So here's a thing. So if you think about a nodevember tree, so this is a tree that I bought from Duck3D for $10. You can reach his Gumroad. You can buy this as well on his Gumroad. And you can see this tree is very huge, and this is completely procedural. However, there are so many values to actually change. Like you have value 1, value 2, value 3, value 4, value 5, value 6. And there are also many other values which I don't know whether there will be criticals to the entire shading or not. But you can also see that there are animated values here and there. So there are so many values scattered around, and if I would like to keyframe all this entire thing, it will be a huge pain, basically intolerable. And if I would like to locate all these important values to one place, then probably I have to like take these values to this place and take where's that? Take that values to that place. And I will feel very lost. Actually, I am feeling very lost about which one is which one. It does not actually. So in that case, we can use animation node, because animation node has a very cool feature. I don't know if later on this feature will be implemented to shader or not, but currently, as far as I know, it's not possible in shader. So I have a viewport input node. So if you have watched many of my demonstration video, I frequently use this node, or actually I exclusively use this node. This node is very interesting. So now I'm connecting this to viewport input node, and I'm not able to change this data. It's because I need to go to viewport input and hit M panels, go to animation node, and change the data from a viewport. So you no longer need to go through all these entire trees. And think about if you have multiple cycles materials for all these data, and put all these values into viewport input, then I'm going to change all these values through viewport input without going to the shader. And all these values are just in one place instead of scattering around this entire huge tree. So it's a huge advantage, which is only available using animation node. But another thing you can realize, there are value. These are all value. So how can I actually know which one is actually the true value that I would like to change? So in this case, you don't necessarily need to worry, because if you hit N, you can see that their name is actually called value 002, value 003, value 004, value 005, and so on. Meaning that if you go to nodevember and you choose the value, you can see there are different values. So this is not a problem, but the problem says there's no animatable input. I actually don't know why this actually happens. I thought this node should be reachable to all these values, but it seems not. But I don't know. Anyway, it actually does not really matter. It turns out to be there is another method for this, which is called expression method. So what I do is I'm going to hang over my mouse to the values, and I'm going to hold Control Shift Alt and then hit C. So I'm copying a data path, and I'm going to define this data to like equals X, and the data says X is not defined. And in this viewport input, I'm going to type float because all these values are essentially float number, and I'm put this float to this new input socket. It will instantaneously create an X. And now you can see, or actually I'm going to use a normal float so that easy to see. So I'm going to use this float control. You can see instantaneously this value turns to be 0 because this float is 0. So I'm going to change the numbers, like if I'm going to change 50, this value turns to be 50 as well. If I'm changing to 25, this value turns to be 25 as well. So this is a very cool part, and of course it works in viewport input. Or sometimes you don't like everything goes to viewport input, you can use another node which is called a group input. Basically it's do the same thing. The only difference, for example, if I'm putting a float and put the float to the place and hit W, invoke node, you can see the float is available here. And it basically is doing the same function. So the basic difference between the viewport input node and the group input is in viewport input, everything is in the viewport. In group input, you also locate all these parameters in one places, but it's in a panel or a node which is only reachable through animation nodes. So something like that. So basically these are two methods available. But you also realize if you change all these values, it changes the entire shader. And as I said in the past, it does not change the value of each object. For example, now that if the spheres turns to be nodevember trees, they basically share the same shaders. So there's no difference between them. So how can I actually make different objects behave differently even if they have the same shader? And this turns out to be a discussion about the falloff, as I mentioned earlier. So let's disable this affecting all shaders and turn on another example. And I'm going to change the node to all transition. You don't need to worry about all these nodes currently. Before we work with falloff, before we work with falloff, so I have a control. You can see this falloff actually works. So within the falloff is blue, and outside the falloff is red. Before I actually explain to you what falloff, how to do all these kind of things, I would mention if you hit T, there is a auto execution panels. Usually, by default, this is actually always. If this is always, then you can see this number is always changing. This number, let's first me disable this. This number actually states the amount of time to execute this node tree. You can see the unit is millisecond, which is very fast. But as it's changing, it means it's just if you turn the always on, it will run this node tree as many times as possible. So right after this execution has been done, it will run the second time and third time, fourth time, fifth time. It will keep running forever. So in short, it will basically burn your computer. So it will be recommended to always keep this always off and turn the rest of the thing on. But if you look at these options, you can have a tree change, frame change, property change. The property actually means the property in these node trees, which means it actually does not doing anything with the falloff. So now I delete the triggers, and if I'm running this falloff, you can see the number on the left upper corner does not change at all, because this falloff is not a part of trigger. So in this case, you just need to add a trigger, and you can choose the object or collection or thing. I usually change the collection, and I just hit the control, and I need to add the location, scale, rotation, ruler. So now if I change the rotation of my object, the tree has been updated. If I'm changing the location of object, the tree has been updated. If I'm changing the scale of my object, the tree has been updated as well. So this is a very important part for this falloff. What else to say? Okay, so let's go back to our node here. So here you can see there is an object color loop node. This is a node that I made for myself because it's actually many nodes, I suppose. Before I really break down this, I just want to show its function. So within the falloff it's blue, and outside the falloff it's red. And it's a shader. See if we view all. You can see it's kind of easy. So the basic principle is I have a vertex color for this object, and I'm putting these colors into factor, and this factor will determine whether it's actually red or blue color. And this is that simple. So within the falloff, it will be blue, and outside the falloff it will be red, something like that. And because this color switch is changing according to the location of falloff. So if I'm duplicating another cube, and I'm going to duplicate this loop as well. Let's hit this cube. So I'm having this loop for two different objects. You can see they are sharing the same materials, but they are having different colors, and they need a location to define. So I just make a objects transform input. I'm taking this cube one locations and take this falloff to falloff. So now if I'm going to change this falloff, you can see only when they're in the region of falloff, they will switch to color. So if I increase this sphere, then both of them can be blue, or both of them can be red, depends on location. So this is how it essentially works. So, and now let's have a breakdown of all these kind of loop. It's called a loop, but it's actually a group node that I've shown you earlier. I call that loop for reasons, but I'm going to make a group input, an object. First thing I need to do is evaluate falloff, and put this falloff back set the type to location, or you can also change the to matrix, but I personally think a location usually will be better. In case every time you need to change all these locations outside, let's just make it inside. Transform object transform input. Put this object in and location to location. So basically what does it means is I'm evaluating, I'm comparing the location of falloff and the location of this object. And by doing so, I'm defining whether this object is within the region of falloff or not. And I'm output a strength which ranges from 0 to 1. And I'm going to combine that to color. So all these values, the maximum number is 1. You can definitely hit that too high, but it's very meaningless. The maximum number is basically 0. The maximum number is 1, and the minimum number is basically 0. And I'm going to change the type to lightness. You can also change that to value, but I actually do not really understand the difference between value and lightness. It seems lightness is really defining whether it's more whitish or more blackish. So I'm going to use lightness, and I'm going to set vertex color. Put this color node into color. Remember to use this vertex color index. I personally realize this is actually very important. And object to object. You can organize this node tree according to your wish, like putting this vertex color layer step before. But essentially, once you made this preset, you won't see this node tree ever again. So I mean, you can still reach that, but it's not very meaningful. So now we have this node. So let's just evoke the subprogram. I mean, hitting W and it goes to right. And let's have some tests about our node. So let's choose our object like cube1, and choose our other objects as cube2, and put falloff to both of them. So now I'm basically evaluating falloff, and it definitely works. It works perfectly fine. And now, because this object transform input has already been in the group node, so you no longer need to have that outside. You just duplicate any, like I'm going to create an icosphere, move that to other places, switch the color into the stuff, and remember to add this vertex color manually, and put the falloff in. Set this object to icosphere. So yeah, when it's outside falloff, it's red, and make it inside falloff, it becomes blue. It works perfectly fine. This is just I'm just talking about the concept. Actually, if you're doing the transform inputs inside the group, sometimes it can cause some certain problems. But I don't want to go too much details. There are so many basics of animation node that I will discuss later. And also, what's actually the difference between the location and the matrix? This is something that I probably will discuss in the future in separate tutorial, but not something I would like to discuss today. And also, a thing that I hope you to realize is now this is I'm only inputting a single object. But what if I would like to input multiple objects? Then you have to make everything into object list. But making this object list also turns to be some other problems. There are so many things I would like you may need to know in other cases, but I don't want to go too much detail in this case. But I just want to mention, so as you know more about animation nodes, later on you can make your own presets, and you can change this preset to make it better. So like originally my preset is like objects color loop. It has a location here, but now we are improving that with the location inside. So things are definitely changing. So there are so many things that we can do with that, and so on and so forth. Anyway, let's go to, oh yeah, here's another thing that I want to mention. The entire principle is the color, black and white, is equivalent to the number from 0 to 1. That's why one inputting color, which is black and white, is actually changing the factor from 0 to 1 and defining the change, which is either blue color or actually red color, and so on and so forth. Meaning that this value can also work in other cases like roughness. So let's just put the principal VCF. So you can see within the falloff it becomes metallic, and outside the falloff it becomes kind of diffuse, whatever stuff. So there are many things you can change, including if I'm mixing shader. Actually, not mixing shader. You can just basically put a color into emission, or you can definitely mixing shader as well. There are so many things you can do. I'm not going to go too much detail, but I suppose you understand the concept. And that's it. So, and here's also another thing I would like to mention is, because you realize if I'm creating a completely new object, like this time let's create a cylinder, let's big cylinder. You can see I don't have vertex color layer. I have to manually add that. What if I have millions of objects? For example, if I'm object instance, I'm going to copy this cylinder for a million times, like 10 times. Now I have all these cylinders. I have 10 cylinders. It looks like not really anything changes because they're in the same locations, but you can definitely move them to other places. So these are 10 cylinders, and they don't have the vertex color layer, and I'm not going to add a layer to all of them. So how can I actually do that? There are many different ways. One way, in terms of object instancer, there is an easy way to do this. You just hit the cylinders and add a vertex color, and remember to click this copy for object. So now if we go to these cylinders, you can see they also have a vertex color. So basically copy full object means you are copying the modifier and the vertex color, or even UV map, many other things together to the same places. And that's it. That's it. There's another cases which this will actually work. So let's remove this instancer, remove this stuff. Let's delete all these objects and let's create a cube, whatever. So now this cube does not have a vertex color. I'm going to use another way to add a vertex color. So basically object mesh data. So I'm selected this object mesh. I'm going to use a node which is called insert vertex color layer. And then it's still not doing anything to that because you need output this mesh. Mesh objects output. So link this to the mesh, it's still nothing happens. So you either click this plus to create a complete new mesh, or you just choose our cube. So you inputting the cube to the mesh and you inserting a vertex color to the mesh to the original object. So this is a kind of idea you can do. These methods can also be used for the mesh that has been created using animation nodes. For example, if I'm having a cylinder mesh, so I'm now going to transform this cube into cylinders, like radius and many other things using Blender. And if I'm just manually add a vertex color, if I'm changing the radius, then this vertex color will actually disappear. But by using this node, then I'm having this vertex color always, regardless how I actually updating the tree. So this is a point. Okay. But sometimes if possible, if you're using instancer, I still recommend you not to use this method because this word space button is will cause some problems sometimes. It's not a bug, but it causes some problems, and I would rather just hitting a vertex color manually instead of doing so. So this is, I think this is done for that part. So in our previous examples, you can see if the object is in falloff, then the entire whole object will transform from red to blue, to metallic to non-metallic, and so on and so forth. But in this example, you can see only the half of only the parts of object that's within the falloff has been changing the colors. So this is kind of more precise gradations and so on. And to do that, there are two methods. One is use the vertex color, as you know earlier, and another is to use the UV mapping. Basically, the principle of doing these two methods are the same, actually very similar. But there are some similarity and difference between the UV map and the vertex color, many other things, and just in conclusion, UV map is rather tends to be a useless node. I personally cannot think of any useful use for that node any longer, and it's for some reason it's slower. I think this is because the vertex color has been updated recently for such a function and blah 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 blah. Anyway, so I will only talk about this vertex color node. But again, they are using the same principles. So if you are interested in, you can just do that for yourself or blah 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 blah. Anyway, so let's break down this node. Again, this node is actually called a loop, but it is in fact a group input again. There's a reason I call it a loop. Maybe you will realize later if you know about animation node or whatever stuff. But again, the name is completely for preference. And I'm going to object mesh data. So this is something different compared to last time. And I'm going to separate polygons. Put the vertices in vertices, and I select this node, hit U, goes to socket settings, and turn on the polygon indices. Or you can go to M panel and turn on polygon indices. That's not really matter. So now I have vertices, and I'm going to take a falloff, evaluate falloff, and turn on the locations. Create a list. So vertices goes to locations, falloff goes to falloff. This is cool. And then I'm going to combine color. And this time again, I'm going to use the lightness. And the strength goes to lightness. But you can see there's no connection because the lightness can only receive one value, unfortunately. So to do that, we have to create a loop. There's also a tutorial talking about how to use the loop, but anyway, you can watch that on my channels. Just use Google or search engine, whatever. And output the color list. Let's change its colors so that it's more obvious. Yeah, now this looks like two different sets. Although this definitely looks like convoluted, like you're increasing 3 nodes, but you just have to do that, unfortunately. And I'm going to use set vertex color. And object to objects, vertex color layer to vertex color layer. Just to mention that this vertex color index is very important because eventually you can create many colors, as many colors and as many layers as you want, and you can have millions of controls for different falloffs. It can be very crazy. But anyway, you might wonder what's the principle of this entire thing. So if you go to UV editing, the vertex color basically works in very similar way. So you have vertices being spread on an image, and essentially you are going to define the color of all these indices, but actually more importantly it's actually the faces. So I need to define the color of these faces, define the color of that faces, these faces, that faces. But if you're going to define the color of these faces using 4 vertices, you can see there is overlapping of vertices. So one vertex actually needs to be 4 vertices, and so on and so forth. That's why you need to separate polygons, generating more vertices, and combine more colors, and set it to set vertex color, so on and so forth. And for UV, and if you would like to change everything to UV, just the UV map data output, and plug these evaluate to X and Y. But I do not recommend you to do that. Just to use this method, even if it looks convoluted. But you won't see all these kind of things ever again once it has been made preset. And by the way, don't get me wrong, you still need these nodes, but you can just hide them on the background. You won't see them. And for example, let's name that a transition test. And now I'm obviously not seeing my nodes, but I'm just calling the transition test that I'm having this preset on hold. So let's just test our node. Oh, and if you would like to really set this in presets, currently there's no really template function available, at least not in my knowledge. The way I usually do is just save all the files, like you can see the entire preset list, and save startup, so on and so forth. And let's test our node and let's see. Yeah, it definitely works. So how can I actually make them colorful? They just like a mix color, mix RGB, make it red, so on and so forth. I mean, I don't know. Like you can take the colors, something like that. You can do a lot of things, even multiply or whatever. I'm just talking about ideas. Once you know the principles, I think you can do many works for that. This is really just telling you the principles. Setting vertex color node is something has been recently updated. Also, beyond what has been mentioned here about all these kind of gradation or transition or other things, you can actually do more than that. You can have other options. Like you can even set the color for polygons. But if you set polygons, then while you're combining the colors, remember to use the polygon center. I don't want to go too much detail in this case. I probably will set that to other tutorial. I think this tutorial has been already too long. So anyway, I hope you get a kind of idea how to use the falloff and all these shaders. And as I mentioned previously, this is completely procedural. Just need to take another node for this object. And if you really know about the animation node, actually this preset does not have to be like this. Like you don't need to replicate it throughout. but I'm not going into too much detail. Anyway, I hope you enjoyed this tutorial, and I really don't want to repeat this. That's why I made this tutorial. I think this tutorial tends to be a little bit longer than I think, but I hope it's helpful for you. And I'll probably see you next time. Bye bye.